Okay, so Tronxy XY-3 Pro V2. This is the new printer from Tronxy 3D. It's brand new, just came from China. It's not available now in Europe, in the European store actually, just from China. So cost first, $399 for the printer, plus, be careful, 70 euro or dollar for the shipment, plus around 1890 import tax. So be careful because the cost is going to be higher if you order now from the China factory. This is just from China. So let's start unboxing, and while we unbox, maybe we go through some specs just close as it came. So let's see what we have there. So while I unbox that,
With this comes with the,
yes, there was a special promotion, exactly.
Yeah.
There was a special promotion and they gave me a free PLA spool. So I probably will use this one as a test. Let's see, who knows?
in Europe.
Yes, it seems like we are very first, kind of very first. So let's try and see what we have inside. So, okay, so this printer, meanwhile, this printer is a direct drive printer. They say this is the best direct drive printer in 2021. That's probably the reason I bought it. No, not really. But anyway, apart from the marketing gimmick, it has good specs in theory. In theory, it has really good specs. So let's see. Protective foam. Here we go. 1, 2. Nice. They gave us also another filament. Another nice spool of filament, which is white. We don't know which brand. Maybe their own filament. Who knows? Anyway, this, for the price of this printer, this is premium price. I mean, $399 plus 70 plus 90, 500, more, 550. I expect some quality to be there because of the price I end up paying. So that's another spool. Nice.
Installation manual.
Installation manual. Let's see. It's color white, black and white.
Black and white.
Black and white. Cheap installation. I'll check this because I'm a nerd about the manuals. So I'll check and I'll tell you if there's spelling errors. English is not my language, but still, I want to make sure that also the manual is good. So manual. We have a nice, what is this? USB adapter and SD card. Let's check. Something Chinese, I think. No Chinese?
Not yet.
Okay, not yet.
It's not white.
It's an 8 gigabyte unbranded SD card. It's gonna work? Who knows?
Hope.
Oh, let's hope so. Let's hope so. Then we have power cable, European, nice from them to send it to European power cable. Then we have, my guess is gonna be spool holder with filament detector. So this printer comes with filament break interruption detection. So if the printer ends, then the filament ends, we can replace it without losing the print, which is a good thing, if it works. Who knows? Then we have, we have the first couple of things. So I found out these T screws here that are just laying around over here. Not bad, not good at all.
With this spatula.
Oh, the spatula is good actually.
Yeah.
The spatula looks kind of good. Higher quality than probably the Ender 3. This is a kind of better quality spatula. We'll see. And then we have this nice pack of things. Let's see. It all seems to be kind of better stuff, no? Like a full screw. While on, for example, Ender 3, they came with just basic stuff. Here it seems like better somehow. We have USB cable. We have a gazillion of our old attaching things, and this is nice. This is easier to install. Yeah, nice. Oh, they also give us a replacement hot end and nozzle. Nice. So we have another one, a spare one, and other screws, nuts, bolts, and tools, and probably whatever we need to set up the printer. Anyway, go. And what else? We do have the bed. The bed, it seems to be a glass bed coated with a texture on it. It's covered by plastic, so it should be pretty safe to use. On both sides, let's see.
No.
No, just on the. What's the point of putting plastic on the back side? Or no, this is the front. This is the front side. Yeah, this is the front side. Damn me, this is the front side. Nice. So this is covered. We'll check later if it's really flat. We'll see. We'll see. Okay, where do we put that?
There.
There, not.
Sure.
That's dangerous. That's dangerous. That no. I'm gonna be dangerous. Okay, here we go. So then next layer. Okay, so the printer comes with another protective material on top of the hot bed. There's a massive scratch here.
But you have a plastic cover.
There's a plastic cover, maybe.
Seems so.
Seems so. We don't know yet, but still, it was pretty damaged, as you see. So it was not sitting slightly where it should have been. That's okay. And then what we have. So this printer, also another good thing about this printer is that it comes almost assembled.
Yeah.
It's just basically two pieces, three pieces. One is the bed, one is the gantries, and that's it. So it should be pretty straightforward to set it up and configure it. Let's pull out something. So first, I will take out this one. What do you think? Yes. This should be the one. Take it out. Okay, just have me out of there. Nice. Those are the gantries. So while we have that, a couple of things that I'm watching that for the first time. So we have two Z rods. So this is good. So it should be very stable, the Z axis. We have two stepper motors, independent stepper motor for the Z axis. There's also a synchronization belt on top, which is a good thing to keep those rods synchronized. Cable management. See the cable management? This could be a good idea or a bad idea. Let's see if that's a good idea or a bad idea.
So here
Also everywhere.
batteries instead of the belt.
You have belts, actually.
Oh, yeah.
See tension belts. Yeah, it's okay. The how to say, the hot end block is not rolling. It's rolling on a kind of steel curve thing. So the wheels are not plastic.
Yeah.
The wheels are metal over metal. It's going to be dangerous. Wearing, who knows? Who knows? But the cable management seems to be very, very clear. Very clear.
And you don't have to mount the belt as in the end.
3, for example.
Yeah.
Yes. It has four wheels to drive this
not
one.
3 like the end of 3.
But still on the Z-axis, you still have the classical wheels to run over. We know that this is not very, how to say, under stress and use. This one is the worst for the movement. So, okay, good. We don't have space. So, let's make it over here. Nice. Okay, let's take out. What do we have here? So we have let's take out this first. We have the hot end. So this is another cool thing. The hot end comes assembled, fully assembled.
Yep.
And it has, it seems like it has a fast connection with the gantry. This could be very nice because of the fact that you can change the entire block. For many reasons. I saw that it's going to be possible at some point to install a laser engraver instead of this one. Or even if you have different nozzle configurations, 04, 02, 01, 08, whatever it is, you can quickly swap in and swap out the entire hot end without having to unscrew the nozzle and do all the stuff.
Having different setup, you can just change.
Very fastly switch over, exactly. This is a BMG style extruder, just the one I like. Dual drive, direct drive,
So
BMG.
you print also rubber with
Yes, TPU.
Yeah.
TPU and ABS. This printer should print almost all the materials known to the planet. No, I'm joking. It can print most of the stuff. So let's see. Here we go. Okay, now we have to take out the bed and move the box away. So here we go.
We lost a wheel.
We lost the wheel. Nice. Yeah.
We keep it.
Can you move it?
Yeah.
Thank you. Let's see. One suggestion if you are new, I don't know, if you're new to 3D printing, my suggestion would be set the tension on the springs to be at the beginning halfway or a high tension, because that will allow you some, how to say, movement when you need to calibrate the bed. So don't just screw it all or leave it all. Just stay in the middle as an entry point. Then you can move from there. Okay, manual. Where do we start from? So, from the beginning, we don't skip, should we? Okay, so blah, 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 they're telling us, okay, the print size is 300 by 300 by 400. So it's a decent print size for the device. Nozzle temperature maximum 275, good, which is for high temperature material. Bed level, they don't tell about the bed. We'll figure it out. Okay, blah, blah, blah. Okay, what do we have here? Installation, upper bracket base. Okay, so we should put that one, obviously enough, on top of this one, and we should screw it with M4 by 10 pieces. Okay. So we have to find out those. Okay. There, I think. So,
no label on it.
No labels. Nice. So we just do guesswork?
Yeah. I think they are the only one.
Okay. Yes. So no labels. Tronxy. And okay. Anyway, let's start. So you want to screw them, and I'll keep it. Okay. Again, when you do the first installation of any printer, I would suggest not to over tight the screws. Just enough. That will allow you to make fine adjustment later down the line. Yeah. So don't over tight them too much. Okay, so how should I grab this printer? This way.
So the first installation with this screw is with the T-Allen, not with the screwdriver inside the...
Okay. Okay, so where do we have to put it? So, okay, here, down there. So we'll be fixing 2 on each side. Don't over tight, just good enough. And then we will fix the other 4 afterward when we have an idea of how it's gonna be. So you have to make sure that the size is aligned correctly. So we will unscrew them, both of them. It's too tight. See, clack? That sound means the screw is too tight. Just don't force it like we did now. So we have space for setting it better and making sure the frame is completely square. So in general, an X configuration for the screws is better than what we did now. So we want to screw, if you have 4 screws, just start with the diagonal one, not the top one, like we did now. Because this is wrong, because then you can bend it this way. But it's a learning process. So let's also do the other one. Now, we will have to connect let's see what they say. We'll have to connect probably this one. So, that's a very nice connector here. I don't know the name for this thing. So, you just plug it in and it clicks in place. Very nice. This, my assumption is that this brings all the nozzle, extruder, uh, control, motors, connection, everything is one side cable that goes from here up to here. That's my guess. Most probably, maybe also the Z. Who knows? Let's see. Next, what do we have over here? We should assemble the hot end part. It's just one screw, they say. This one. Okay. So, with a shower in the middle. Washer, that's my English. Okay. So it has to be this way. So let me show you. So it's here. It's here.
It's already there. Okay.
Yes. We just need a washer. A washer.
We don't have that.
We don't have that?
No.
Nice. So we don't have the washer. It's gonna be fine. I can use one of mine. That's gonna be fine. So the illustration says to use a washer, but we don't. They don't include one.
The thing with the.
Okay. So I'll have one. I'll use one of mine. Let's see. Okay, and then this is very simple to install. So it has two holes on the back to hold for these two screws down here, and then you just slide it in so it holds there, and then you screw it on the top. And that's how you install and replace the hot end. This is nice. This is very nice. Is it stable? Yes, it is.
I think so.
Yes. So that's very good. So this is how you install it. My guess, we will have to also somehow power it up by, I don't know, hook, cable. What should we do with that?
Here maybe?
This one maybe here. We have no idea. We guess that. So we guess that this is gonna be installed over here, but we'll see. They don't mention that. So, okay, the hot end is installed, as they say. They tell us to install the spool holder. Okay, let's get it. Okay, so how do we have to install it? They want it to be, doesn't really matter, but they say it's gonna be this way. Huh, I don't like it much. No, it doesn't make any sense, the illustration they use, because then you have this lands exactly in the middle of the.
You have these two, probably.
Yes, that's for fixing it.
Yeah.
But the issue is that it just touches the belt, which is not how it's supposed to be. So I'm not gonna do that, honestly. Not the way they show, at least, because this is supposed to be, I know you can see that, but this is supposed to be this way. But when you install it this way, the how to say, synchronization belt that goes between axes is touching here. So we don't want that to happen at all. So, and also this is the, how to say, the filament sensor. So I don't want to do it. That is probably the powering of the thing. So it's supposed to be here.
Yeah.
But see, the filament feeds. It can't be this way. Can it be?
No.
I don't think so.
Maybe this way, but yeah.
It's touching. It's not a good. Maybe we can move this thing. The filament is gonna go through from the spool over here, and then down there up to here.
Yeah.
So, how do we get there? To me, it would have been way more logical to have it this way. So the filament goes from here, down here, up to here.
Yeah.
My guess, but then way. So I would do it this way.
Okay.
Maybe it's just me. Let's do it. Let's do it. Do it my way. No,
And
like somebody
eventually
says.
you can unscrew it
And do it again.
unwiring and move it.
Okay, let's do it this way. Now I'll just it's almost in the middle, and how to close these screws? Simple. You just untwist them a little bit and then twist them. They should just rotate in place. So untwist them and then twist them again, and they should just somehow rotate to the right position, and that should be sticky enough. Good. This is how I see it has to be installed. Let's see if I'm right or if I'm wrong. Who knows? Okay, so next we have the nice wiring diagram. The first thing they tell us is to plug this one. This is the filament detector cable. It is labeled filament stop. Let's call it filament stop. Say good enough.
It's a nice hint.
It's a nice hint of what it should be. Just plug in. Yes, just to be plugged in this way. Just that. Okay, plugged in. Nice. Then we should move down where? What do they say? Down.
Here you have USB connection.
Yes. Is there a cable over there?
This one here.
This one. Okay, we just do it freeway. So we will install first the one for the Z motors. The other way. Okay. Okay. And then, okay, one thing to note, while I'm freely installing, because this manual is not very clear, okay, make sure that the voltage is set to your country voltage. To us in Italy, it's 220, so it's already coming with 230, which is okay. Otherwise, make sure you check it, because you can burn it. You will burn it, actually. So, that's another tip. Is there any other cable that we should connect? We are supposed to connect? Let's see. Power, this thing, USB, SD, this one on the Z. That's that one. So let's see that one. Adapter, okay, this one I plugged that before, which was the right motor, left motor, slots, power switch card slot, they don't, okay. Then insert the FPC cord. So we have to insert the FTP toggle, the black buckle, insert, restore the black buckle, make the cord is secured. So there's a buckle somehow on the front side. Sorry, there's a buckle. Let's do this way. Let's turn it a little bit. Okay, there's a buckle here. Okay. There's a buckle that is open and closed. Fine. So we will have to install it here. We have to check all the eccentric nuts. So what are the eccentric nuts? Especially these wheels, I don't know if they have them, but all the wheels may be, wobbling, like this one is wobbling. This one is over tight. So eccentric nuts will allow us to better configure those wheels to be gripping just enough. So let's start from this one, for example. There's no direction when to turn it. You have to try, because it's eccentric, so the center of the nut is not exactly in the center, so we don't know where it is now. We'll just have to try and see where we start seeing some difference in the nut. So let's see if we can make it rotate a little bit better. This is still way far down the line. This is free now. This is free now. This is over tight. So let's play again. good enough for now. We'll fix them as the first runs. Okay, eccentric nuts, they are good. Okay, also the one on the bed. Let's see how. Okay, the first thing you should check is the wobbling. This is pretty solid, okay? Seems to be good. Check it on the other side, the wheels. Seems good. On the bottom side, we should be good. Okay, so let's install now the bed. Okay, this is the bed. Don't exactly, thank you so much. Okay, let's get some dirt. It's very in a bad shape. It's just scratched all over. It's not like really the quality I would expect, but that's okay.
On the bottom you have some.
That's okay. Yeah. There's the.
I don't know if you have to peel it.
No. That's okay this way. This is thermal insulation protection that is supposed to be there.
Yeah.
So it just holds the, how to say, the thermal heating there. So, so let's put this one, let's peel it off, which is important to peel it off.
The most satisfying
Ah,
in the world.
here we go. And then we will do what we do usually. So we will set one on this left side, one on this right side.
This is very good, I think, having the
This side,
guideline,
this side. Always diagonally install the screws. That's important. Because then you can keep the things. One nice touch is that they give you the markers. So you know where to put them. You just put them there, not too much, don't turn them too much, just a little bit, to make a little bit of pressure. Okay, that was easy. That was super easy. Are we good to go? Maybe. So, let's connect the printer to the power supply and see if we smoke it. One last check. 200, always 220. Make sure that's 220. Yeah, let's peel off this one. Nice. Okay. Power cord. Okay. Let's put it down here. Nice. It started. Yay! A nice welcoming sound. Okay, so there's a nice crisp LCD on the front. Very. It's beautiful. It's beautiful. And you have 3 settings: system, tools, and print. Let's see what they tell us to do. They just they don't tell us much. They show us all the feature, where you can go to do it, auto leveling, and whatever it is. So yeah, this printer comes with an auto leveling feature. So the benefit is that it has a kind of, I don't know, BL touch, but it's not a BL touch. It's a different technology. It doesn't touch. It's just a distance proximity sensor. So it should help calibrating the bed. We will just follow the instruction and see what happens. No, so they tell us to just select tools. Should we do that? Tool, nice. And then it seemed very responsive, the touch, which is important. Click on level, and then please choose the level mode. And they say to, if the absolute, okay, auto. Let's see what it does. It's moving. Okay, this is another thing. The end stop switch, it's digital somehow. It's not like a clicky thing. Now it's trying to go to the center. Okay, what is the power off switch? I want to be sure in case something bad happens, because I crashed into the bed so many times. I want to make sure we don't destroy anything. So just follow the instruction. Let's go down there. Let's see, it's approaching the bed. It's approaching. It's approaching. Nice. I was so scared. Just a proximity sensor. Nice, right? See? Nice. This is nice. If it works, this is absolutely nice. Nice. It's gonna be fun because we have this super leveled bed, no? High leveled. Very nice high leveled. This is very nice. So they say to go through the entire process, and if you have any value that where it's greater than 0.8, adjust the screw and do it again. So this is nice because it's showing in order here which value they read over the thing. So we have 1 point, this one, which is 0.8. So we are far. So let's see. We'll do it again. So far, it is very promising. Very promising. Something happened. Okay, we lost that one. Fine. Nothing big, nothing bad. We just do it again. Okay. So, let's do it again. Thank you. Let's screw it. Okay. Okay. So, this is very nice because we have the entire reading of the bed. So what it says that if the absolute value of the difference, difference of what doesn't matter, is greater than 0.5, so they are straighter than the manual, just adjust the screw and do it again. Adjust the screw. So I would have to fix this one mostly because it's 0.8 and the other one are pretty okay. So let's do it again. So let's move the axis. Okay, can I move it faster? No, I have to double tap. That's, I would have loved to be able to just keep it pushed and move. Why I have to touch each time I want to move it. So now, what I want to do, I want to screw it a little bit more. This way or a bit less. Let's try it this way. So I'll run it again and see how it went, and then I'll decide what to do. So let's go again, level, auto, and see where we go from there. In the meantime, I'll open their filament. Let's see what they offer. I don't even remember the color for that. Not which.
It's the white one.
It's a white one. No, I hope not.
Guess.
No, I hope not. Why? I don't want a white one. That's the white one. I want a color one, like a shiny freaking color thing. 1 point. That was my bad. So it has to be tightened more. So could we cancel this right away? Can I cancel it? Failed. Fine. I know it's gonna fail. So let me tighten it. Okay. Let's level auto. Green, yes. We love colors. Drum roll. 02. Yes, I did it. I should probably better level the entire thing, but let's do what they do. So 0.5. So this is almost slightly perfect. Perfect. Thank you. So this is Tronxy Green PLA. Let's give them the chance. Why not? -0, -4. Nice. It is just a classical. There. Just a classical spool, so there's nothing fancy to it. Literally nothing fancy to it. This is also very satisfying to open the spool without cutting yourself. Okay. So far it seems to be okay. We could improve where? Somewhere, but that's okay. We don't want to be perfect. Who is perfect at this one? Okay, now one question. In the kit, there was a crimper, a cutter, a small cutter. Ah, that's a bad thing. Okay. Be ready to cut your own. See, this is one of the, this is one of the things that makes the Tronxy could do better. If you ask me to cut them 45 degrees to load the filament, which is a good instruction, but you don't give me a cutter, a first-time printer would have issues with this thing. So, this is okay. So, now we did this, auto leveling. Now we go to the Z offset. So let's see Z offset. And it says, according to the actual situation, use 10, 1 or 0.1 to adjust the distance between the nozzle and the platform and adjust it into the thickness of A4 paper. Fine, it's horrible English explanation, but I understand what they asked me to do. So I'll try to make the nozzle just grip on the paper. Now, yeah, okay, I don't know if the bed is heated or, I don't really do that with a heated bed, but this is freaking cold. So let me preheat the bed because I want to do this with the bed heated. I will repeat everything with the bed heated because this is how I do it. If you have suggestion why I shouldn't do that, just let me know. So system, English default, TPA adjust, print mode, no. Tool, preheat. I want to eat the... Okay, this is not very clear. This is the extruder 1, extruder 2, which we don't have. And the big flame, the forest fire, it seems to be the bed, maybe. I don't know. Let's set it to 50, which is what I... Okay, this is another thing. It does 0.4 increments. So I want to set it to 50. It just goes 4 by 4. And I don't want to do 4 by 4. I want to do 6. I want to do 50, and it just doesn't. Fine, 60. I'd prefer 50, but that's okay. And then the nozzle temperature. And again, I cannot keep pushing, and you just have to push every time. So, but in this case, it doesn't really matter how much I set the nozzle. Let's set it to something reasonable like 170, 180, just before the melting temperature. So I would have, how to say, closer to operation configuration. 168 is going to be fine. The fan started. Let me let you hear the noise of the fan. Nice. The bed is preheating. We are at 37 out of 60, 38. The sound is not like a wonderful sound, but we don't know where it comes from. Pretty noisy.
It's using probably an engine from a beetle.
No way. But where it comes from? from here somehow. It does a cracking noise. Who knows? Who knows? Okay, so we reached the nozzle temperature. It smells like burn a little bit. Finger crossed it's gonna be fine.
This noise for sure is not digital.
This noise is analog, that's for sure. Okay, so we are preheating. So it's getting to the bed temperature. It's pretty slow now that we reached 47. To me, it's kind of good enough because I was aiming at 50. So it's kind of good enough. Maybe we will need to do some PID tuning to get it to perform better. But anyway, let's do again the procedure of leveling to see if heating the bed somehow impacted the warpness of the bed. I'm starting to hate that fan noise. This is very loud. Okay, the first point. 0.1. See, it's way different than before. So it does make a difference. I tend to love to level the bed at printing temperature. I do print PLA, so it's 50, 60, 200. I don't want to. The reason why I didn't set the nozzle temperature to 200 or 210 is because I don't want it to start melting. In this case, that's dumb me. I don't have any filament, so it would have been nice, even fine, to heat it up more, but that's okay. That's okay. I want to be used to set it to 170, 180. And yes, I still don't know if the sensor has some kind of, if you make multiple runs, you get multiple very different values, or it's just the bed temperature that helped. I don't know, but anyway, let it go. It's almost finished. Check the temperature. This is okay. We didn't check the tension. It's hard to check the tension over here of the belts. But anyway, we'll see. Okay, so auto leveling done. And all the distances, see there on the back we have a wrong reading, so I'll just screw it a little bit. Okay, and let's do level again. It's gonna be a boring process, but that's how life is. All seems okay now. Well done. Now, Z offset. We'll bring it Z in, and then I'll do how they say, that's fun. They say, based on, according to the actual situation. That's a hard situation. It's always a hard situation. Okay. We are way far, so 0.1 is going down. I don't understand. 0.1. Down. 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 It's so high. How high are you? You are massively high. 1 millimeter. Down. Is it getting closer? Yes. Too much. Up. Yes, now let's go gradually. Too much. So we want to be even more gradual. Yes. Okay, this is the kind, let's see. This is the kind of grip I want. This is it. Okay. And then what should I do? Select, finally click set as 0. Set as 0. Set as 0. No feedback. So I am assuming it's okay. Fine. So let's move up the Y a little bit. No, sorry, the Z a little bit. Because now we are loading the filament. I want to give some headroom for the film. Okay, 10 millimeter each step. No, that's extruder. I don't know what they mean. Okay, that's good enough. So, now that the loading filament needs to perform some necessary operations shown below. Straighten the filament, I understand that. And we let it pass by. And then, so, take the filament. Okay, Tronxy nice PLA. So my guess, load it. So we make it, okay, can I cut it? Yeah. So let's first cut it, 40 degrees, 45 degrees as they say, which is a good suggestion, which is a very good suggestion. Maybe the other way around. I am that dumb? No, I was right. Yes, and we can do also some advertising for them. So let's get it through here. So we are not monkeys, so let's just do it this way. Can we get it through this one? Okay, when it passed by, a blue light started up, meaning that it detected the filament, which is a good thing. Then we go slowly. This is a mistake. This is a big mistake. Okay, we go down here. And then we have to straighten it a little bit. Yes, because that's one of the nicest tricks. Just straighten the filament to make it easy to pass through. Now I'm not able to do that, but anyway, that's okay. And then you put the filament down into this Bowden tube. That's my guess, it's a Bowden tube. Yes. And then it says tool preheat. Then it says to set the temperature to 200 degrees, of course. So we go back, we go to preheat, we set the temperature now to 200, yes, and we'll have to wait for it to reach 200. Preheat the nozzle, yes, I know how to do it. Then when it's heated, now it's 178, it's pretty fast heating the nozzle, yeah, it's okay. My guess is that we'll have to help it out a little bit, but they don't tell it to do this thing. Okay, it smells like ish, but that's okay. So it's 194. It needs definitely some PID tuning, that's for sure. But anyway, let's do what they say. We go to filament, then it says to extruded filament, unload filament. Okay, so it's not very clear, but this is E for extrude. So we clearly see this rolling, and we are getting filament out. That was pretty easy.
Good.
Okay, so there was some white one inside. So my guess is that they tested the printer, yeah, because there was white filament in the tank. But the loading process was very straightforward, very straightforward. We let it go for a while. Okay, and I think that's how to stop it. We just stop it. Nice. Here we go. So it all worked pretty nice. Fine. Fine, just throw it, doesn't matter. Okay, print test. How do we print test? Yeah, we are here for the printing. So back. We'll go now to print. And there's nothing. There's nothing because we don't have the SD card. See, Fabio? They are right. So we plug in the SD card that comes with the printer. I think yes, that's the case. Then we go to print. Oh, and there's one file. There's one file. It's not a calibration cube. It's something different. Let's see. Okay. Cura slicing software. Oh no, I did something wrong. Very wrong. Vase calibration cube. The instructions are not correct, probably, but it's the same thing. The good thing is that it can see G-code files inside folders, which is somehow a good thing for some printers. So let's start this calibration cube, and let's see what we get. So they say to start a calibration cube, start printing, and they of course check I tell you to check the level of this calibration cube, G-code, nothing shows up. I would say play. Filament run out, docking aside. What do you mean by filament run out, docking aside? Insert new material and press OK to continue. Okay. This one goes down here, goes down here, that goes down here, that goes into here. So all seems okay. Oh my. See, that's the issue. Look at this one. Can you see the cable?
Yeah.
So the cable has been eaten somehow by something. So my guess is that something is not okay here by the cable. And the filament detection is not sending the commands the right way. Back. Eating now, please wait. It's now worked. So there's something over here.
Okay.
It seems like, see, the connection here, just not right. Now it's sitting again. This was not a very smart choice to let it run through the wheels. Yeah. It's printing. Is it?
Not at all.
Not at all, but it says it's printing. 2%. Okay, because the bed temperature is not still there, so it's still eating up.
So eating up is part of the process while printing?
Yes, yes.
It's considered during the
Yes, it's
first
part of the
frame.
print time. Yes,
Okay.
eating up is part of the print time. Most of the time, yes, that's the way it is. So the bed is 59 out of 60. The nozzle is 195 out of 200, so we should be pretty close to it. Let's see. 96, 97. Come on. It's expect the print time of 30 minutes. We will just time lapse this thing, this part. So we'll see how the calibration cube came out. Ready? Here we go. So let's see what the printer does. The question would be, does it auto level automatically each time? Just I have to do it? Who knows? This was the right setting for the thing. Okay, it's approaching. It's approaching. It's a lot twisted. This is very twisted. But anyway. Okay. It did some kind of setting. Filament run out. So, what I'll do now, I think we have an issue with the filament detection cable, which is like in a bad shape here, because it just runs under the wheel, and that is the, see, the crazy part of this thing. It just runs under this wheel.
Probably supposed to be inside this guy, but we lost it there. Should be.
How it should be. Okay, let's turn the printer off. Let's see if we can fix it fast. So, is it sticked inside here? With what? With glue? What if we take it out and we go outside?
I think it's the best.
It's a good idea.
Yeah.
Let's just unscrew. See, it's all glue. It's all glue sticked. This thing, we don't want to do it. See if we can fix it fast. Finger crossed we're gonna be able to pass this down. Okay, can do that. This, no. No, right? Cannot do this thing. Always keep hope. Always keep hope. So what I'll do, I'll make it stay here. So, okay, here we go. Okay, it's plugged in. And we will make it so, just give some headroom to go down, it's okay. So we'll just keep it for now here. There's nothing rolling, so we can just hold it. Can we hold it over there? Yes. It's very rude fix, but this is, okay. This could be the way, because this is, we will have to change the cable somehow, because this is damaged. Okay, let's try again. Cancel. No. Let me print it. Down. Calibration cube. Print. If it doesn't work, we'll just exclude the filament sensor completely for now. It could be because this part has been, I don't know if you can see that, but this part has been damaged. So moving up and down, it could create some contacts, and this can report a filament run out because it sees the cutting of the power. So we'll see, now we are eating back. We are almost there. We'll try to see what happens when it moves. If it does, I will unload the filament, I will remove the filament, or I will just disconnect the filament sensor. So in theory, you would not see the filament sensor available, and that would help out to let it go anyway. Let's see. Finger crossed. This probably these wires should have been down here, but then pulled out somewhere. Before, not after the wire, after the wheels. My guess, my opinion.
Or better glued on the bottom.
On the bottom, so it just comes from the bottom. Who knows? It does print. I mean, it's pretend to be printing. Nothing comes out.
No. Probably the PLA is stuck in the extruder.
Oh no, nothing is coming out. Okay, so let's tune. How do we tune the 8? We cannot tune the 8? Serious? Board on, cold, 0. Okay, nothing is coming out. First failure. So the print finished successfully, our calibration cube. So I now want to measure the cube. So let's see how it is. So nice, cool. This glass bed, once cooled down, it can things just pop off right away. So it's super easy to pop them off. So let's see how is this cube. So X 199.95. Very nice. Let's measure another spot. 1982. 1986. Could have done better. 1989. Let's see the Y. Let's see the Y, how it is. Oops. Y is gonna be 1995. Let me do that this way, so maybe it's easier to see. 2022, let's do it better. 2018. I've seen better. Z is 2004. Wow, 2004. Not bad. So what I'll do now, I'll go ahead, I'll print out of stuff, and we'll check back to see how that goes. So here we go. After a week of printing, this is the result. So does the printer print? Yes, it does. I used both the green included filament and of course an airy one blue filament. This is my final thoughts about the printer. Of course, a printer needs time to see how it performs over time, which issue may arise. So what I'm telling you now is just about here and now, after a week. So I had a couple of issues. First of all, how it came from the factory, it had a physical issue on the hot end socket, silicon socket. If you can see that, it was bent. So how the printer is designed is that the airflow to cool down the printed part comes exactly under the socket. If the socket, because of being a little bit loose, just falls a little bit, all the airflow gets, how to say, overridden by the socket. This way, I had a lot of stringing issue, a lot of other issues that I just figured it out. So this was the first issue. Second, I had some weird noises, so I but I disassembled all the belts, X gantry, Y gantry, all the belts, and I reassembled them back, and the noise went away. So my guess is that there was something about the installation that didn't went right. Also, the belts were not tight. This printer goes fast. So going fast, you need a very tight belts, very substantially tight belts. So I tried to tie the belt. Unfortunately, as you can see from here, there's an orange part over here. The belt tension at the maximum wasn't pulling enough on the belt, so this belt was still loose. So I designed and printed myself a pre-tensioner for the belt, so I could get some more tension on the belt, and it worked. So this belt now is the X gantry belt is very tight, just right. So it's good. I have to, unfortunately, how it's designed on the Y gantry, I cannot Y axis. I cannot put a pre-tensioner like this one. I'll have to design something slightly different. So I'll work on that, and eventually I'll do it to allow some more tension, because right now the Y belt is not doesn't have enough tension, at least not the one I want. What I did also, I disassembled all the hot end. I changed the nozzle to a new nozzle, the one that comes, a replacement nozzle, because I was having also issue with that one. Now this one works way better. And so those are the big things. Now, the other thing is about the software and profiles. This printer comes with a Marlin firmware, open source, supposedly open source. Unfortunately, as of today, I contacted the technical support that, by the way, it was very responsive. I know people had bad experiences with Tronxy support. I didn't. I didn't told them I was going to make a video review. It was just me as a standard user sending them question. I always got an answer in one day. Was it satisfying? Not all the time. I told them about the issue that, if you remember, about this filament runout detector cable being badly installed from the factory. They just replied to me, yes, that's correct, just replace it. No, I was hoping for a replacement part from you, not me replacing that. Anyway, I also asked them about, what about the firmware? I wanted to use eventually Clipper, Octoprint, Octopi, whatever. I want to do more. I want to use UBL from Marlin, Unified Bed Leveling. I want to do more, but the firmware is not open sourced yet from them. They said it's coming. It's coming. They have an issue with multi-language support. I don't know exactly what they mean, but they said it's going to be released, but it's not available as of today. Finger crossed it's going to be. And if it's going to be, I'll be working on that. One thing to remember is that one of the biggest issue I got is that the Cura version, the Cura profile, the Cura setting on the manual, they are wrong. They are settings copied from a Bowden printer, not a direct drive. So all the retraction settings are wrong, all the speeds are wrong. So I went through and I did a lot of, as you can see there, a lot of cubes, temperature tower, retraction towers, all these kind of things to build up and create a Cura profile that could work with this printer. I did it. I mean, it needs improvement. It can be improved, and I'm hoping for your input to improve it more. But as you can see, it's working. It's working way better than what they suggest. So at the bottom of this video, you will find links to a GitHub page, my GitHub page, where you will find all these things, including the 3D project and STL file for the X-gantry pre-tensioner. You will find my Cura profile, my Cura printer. Of course, I changed also, and I crafted my own Cura start G-code for the printer. So when the printer starts, it does a nozzle cleanup sequence, and then start printing to avoid blobs and things like that. You will find the machine settings, everything over there.
You will find also the community from Tronxy, both
Yes.
from Facebook page and Facebook community, sorry, and the
Correct.
the
Discord server.
Discord.
So at the bottom of the video, we will put also the links to their community, which is a Facebook group mostly, and a Discord server. Guys, please go and sign up, because this community is great. A lot of people willing to help and very experienced in 3D printing. So to sum up, how I would rate this printer. This printer has an issue, is the software. The software is buggy, is limited. It's very limited. And I'm referring mostly to the UI. The UI is exactly limited. You cannot do, for example, Z offset tuning while printing. When you slice with Cura, it doesn't correctly handle the printing time, because the board is a Key2 board. So it needs special G-code commands to allow preview. And I went through the process of installing and testing the Key2 board plugin C2 Writer, a link that we will find in the description, for plugin for Cura, and I could not get it to work. I'll do more and see what I can get, but the issue is the software. The software is very, very limited. I was hoping to get the open source version and improve it myself, but they won't give it to me yet. So you will have to live with this software. There are some mechanically speaking, it's a good printer. I think it's a good printer. It has good stuff, but there are some flaws. One is the one I told you, this socket, which is not good. But also, for some reason, and I still have to investigate that, all the belts, the X belt and the Y belt, on the side of the stepper motor, they have a gear to drive the belt. On the other side, they don't have a gear. They have a simple tensioner, round tensioner, just to let the tension on the belt, and the bear goes around this tensioner, which I think it can slip, especially at high speed. So my next upgrade is going to be to replace this tensioner over here, not mine, but the ring tensioner, and the one back here on the Y-axis with geared version to have a more stable grip on the belt. That's one of the upgrades I'm going to do to see if I can improve the overall print quality. I'm going to replace the firmware and, of course, try to use Octoprint and Octopi, and maybe Clipper if I get it to work. I will be designing probably a new piece over here as a spool holder. I want this spool holder to be placed differently. I want it to be placed this way. So I want this spool to be facing the printer this way. So I'll design an adapter to be able to change the spool holder, because I think this setup is too tight. This should be in a different way. So I'll print it and I will share it in the GitHub page, so you can also have it. If you happen to have upgrades, just let me know. Anything I'll be interested in, so let me know what you have over here. Should you buy this printer? Yes. If it's your first printer, no. I would say this is a printer for somebody who knows what they are doing, just because of the software limitation. It's a direct drive. It's not easy to manage as a Bowden one. It's powerful, probably, yes. Yes, probably it's powerful than a Bowden one. I would say because of the technology, BMG clone extruder, all metal hot-end and all this stuff, I wouldn't suggest this as a first printer. Still, it has a lot of potential. Mind the software. That is the biggest weakness of this printer. One other weakness is the fact that it's being extremely new. There's not very much people using it, so not much community support for the printer. Yes, you have general community support, but not for this specific printer. I'm willing to help, of course, but so far I could not find anybody else in the community having this printer. So expect to be on your own most of the time. But if you are an experienced or somebody who already has a printer, Artillery, Creality, some other printers, then you may try this one. This one is very promising. I know when the software comes out open source, it's going to be a good printer. This is going to be really a good printer. Anyway, my plan is to make another video, maybe in a couple of weeks, maybe a month, after I make all my, I think, due updates. And I'll make a print comparison of what I have now compared to what I'll get after the upgrades. And finger crossed, we will get also the new Marlin open source. So I can also try, for example, to use UBL. Couple of things that people ask me. What about the auto leveling sensor? Tronxy is known to have a very bad auto leveling sensor that failed a lot of time. This one is the new model. The old one, I think it was blue. This one is black. It used a different technology. To me, it never failed. It was exactly on spot all the time. All the ABL session was repeatable. I could get the same value between a tenth, hundredths of a millimeter precision every time. So I can't say more than saying that this is a good leveling technology. Probably comparable, if not even better, to known BL touch and 3D touch and all these touch-based solutions. So I would say this is the way to go. This is a very good solution. This printer is noisy. It's pretty noisy because of metal over metal wheels, fans, very noisy fans over here, board fan, very noisy. So it's a noisy printer. You want a silent printing, that's not the board for you, not machine for you. The stepper motors are noisy. It's not a it's not a quiet printer. Still great potential. Okay, I think that's it for now, but I want to get back to this printer because I like it. As much as it gave me crazy times, I like this printer. And I want to give you more information as much as possible. So please, again, as a reminder, like this video if you want, subscribe to this channel if we will ever make another video, maybe another one for sure, we don't know yet. But if you want to subscribe, just subscribe. And please go to the community, Discord channel server. The guys over there are very nice, and also the Facebook group. Okay, thank you, enjoy, and see you at the next video. Bye.
Bye.